Okay, now that I called this up, I think what I did was I had talked about it in general, and we didn't do any examples. Okay, I think that's where we were. So the difference between two squares, remember, is that a plus b times a minus b, and you get a squared minus b squared. The sum of two squares, a squared plus b squared, doesn't factor. Now, if we go to cubes, the sum and the difference of two cubes both factor. So if we have a cubed plus b cubed, that will factor, and a cubed minus b cubed will factor. So one of the things I encourage you to do is just get familiar with these numbers because they're perfect cubes. 1 is 1 cubed, 8 is 2 cubed, 27 is 3 cubed, 64 is 4 cubed, 5 is, or 125 is 5 cubed, 6 cubed is 216. Don't worry so much about 7, 8, and 9. Probably won't throw those at you, but of course 1,000 is easy, that's 10. So those are the cubes that I think you should recognize. Particularly the ones that are, 27, 64, 125, and 216 are probably not that familiar to you. So as you practice these and do your homework and everything, just start, noticing those numbers as cubes. Okay, so let's look at the way cubes factor. And there's no real way to justify this other than somebody somewhere along the line took these two polynomials, this trinomial and this binomial, multiplied them together, and notice they got the sum of the cubes, and they did the same thing with this one and got the difference of the cubes. Now this is something that I would like you to remember. All right, so these are pretty ugly formulas, so let's talk about how you're going to memorize them. Okay, notice that the signs of this first binomial form is the same as what the original polynomial is. Okay, so they're both negative. So we have u cubed minus v cubed is u minus v. Now, each of them have one negative in them, and so the middle term in the second one is positive here, and it's negative here. So remember, you always have one negative, and the one negative that shows up for the difference is in the binomial term. The negative shows up in the trinomial term for the sum. So if you just remember they have one negative sign, and remember what the first term is, the second one falls in place. Now notice there's no numeric coefficients here either. When we get to this point, this u squared minus uv plus v squared, that won't ever factor. Okay, so we're going to get into some expressions where u and v are more than just a single variable. No matter how that turns out, you will never be able to factor these two. So once you either have the sum or the difference in cubes, once you get these two factors, you're done. It won't be able to factor anymore. Unlike when you have other forms, you could factor something and then factor it again and keep on factoring until you get to its prime factors. You will be at its prime factors when you get to this point. So let me take you through a couple examples here. So the easiest one is just u cubed plus 1, or x cubed minus 1 plus 1. Gosh, I'm not speaking properly. Okay, so 1 is always a cube because that's 1 cube, so I have 2 cubes. And so I just expand that into my formula of x plus 1, take that, times, and then in parentheses, x squared minus x plus 1. Okay, so it's the sum, so this one's positive. You have one negative, and that's where the negative goes. This does not factor, x squared minus x plus 1. All right, so if we have something other than a 1, like we have x cubed plus 8, think of that as x cubed plus 2 cubed. Now you have the 2 cubes. And it'll be helpful for you to write this too, to write what you're cubing, because whenever you're substituting it back into these factored forms, you're not going to use the 8. You're going to use the 2 and do whatever to the 2, whatever you need to do to the 2 to make that expression work. So we'll factor this out. This comes out to be x plus 2 times x squared minus 2x plus 2 squared, and of course we'll simplify that last 2 squared to 4, so this is the way it looks, all right? So even though this was an 8 and it's cubed, this one back here is going to be a 4, which is a perfect square. All right, and that's kind of the thing to remember here, is that you need to carry over the right term. That's why I advise you to, rewrite it 2 cubed, so you see that 2 is the one that you carry on through, not the 8. All right, then if we have one with a negative sign in it, 27 is 3 cubed, so we can write that as x cubed minus 3 cubed. And then when we put it in the factored form, it's x minus 3 plus x squared plus 3x plus 9. So our negative was in this first pair. So in the trinomial term, we have a positive, and this last term is going to be 3 squared, which is 9, and this is just plain old 3 because we have uv. So in this case, it's 3, which was the old v, and x is the old u. Okay, so it's just a matter of a form, putting it in. Might be a good exercise for you just to take this and multiply it out. You'll see that all the terms except the first and the last one cancel out. And so there's really, other than a strict memorization, there's not too many ways that you can derive this one unless you're really, really clever. Okay, so I'll copy over the forms just to keep them in mind. I know I just introduced them. So I'd like you to try these, all right? I want you to factor these, and we'll see where we go, okay? The first two should be fairly straightforward. The second one has a little twist in it. Okay. I still see some of you writing, so I'll give you a little bit more time. Okay, who has the second one? Anybody? Anybody have it? Ivan, did you get it?
Z plus 5 times z squared minus 5z plus 25.
Great. Okay, just like that. And how about the third one? Anybody have a chance to look at that? How does that rewrite into the difference of cubes? That would be the first step.
2 cubes, t cubed minus 3 cubed.
Right, okay, so we would want to rewrite that like this, and then use that as your as the basis for doing the factoring. Okay, so then we'll put those in. So we have the 2t minus 3. We have the negative sign, so we're using the negative first. And then we're going to take that 2t squared, which makes 4t squared, and then we're going to take 2t times 3, and we get 6t, and then we get 3 squared, which is 9. Okay, so you see how that first 2 goes on through, that when we're squaring that term, it gets squared, and when we don't square it, it doesn't square. And then, of course, the one negative sign we have is here, and all of these terms are then positive. All right, so let's kind of loop back to the beginning. One of the things that is the hardest to remember often is to factor out common monomials. All right, so I want to say that again. So the first time you look at a polynomial, look through it and say what one single monomial factor is common through all of them. This will save you a lot in terms of doing additional factoring after you've done the first factoring step. Okay, then what you want to do is you want to factor out a -1 when it's the leading term. And then we're going to check for special forms. All right, so here's a few that we don't need to do anything except the things that we've covered so far. And I'd like you to do these. They're not necessarily the difference between cubes, okay? Like that second one is not the difference between two cubes. So you got to think back a little earlier to some of the special forms that involved something of that sort. I'll give you a few minutes here. Display that then. Okay, so now on the second one, we have x to the 4th minus 1. And one of the ways to look at that 4th degree is to think that that's a squared square, right? So if we have something like this, now we have the difference between two squares. And so that factors into x squared plus 1 times x squared minus 1. But at this point, we're not done, right? X squared plus 1 doesn't factor, but x squared minus 1 does. And so then the second step would be to make it like this. And then we're done. Okay, so to make this point, you look at the exponents, and because it's even means that it's a square. Okay, if it was odd, you'd have to ask yourself, is it a cube? Is it like x to the 9th or x to the 27th or something like that? But here we have an even number, so that's a squared. Okay, so we have that there. Now this last one, anybody suggest approach? What's the first thing that we do here? What would be the first thing?
Take out a 6.
Take out a 6, great. Okay, so then we would end up with 6 times x to the 6th minus 8y to the 6th. Okay, now what about this now? Okay, we can look at this one as the difference between two cubes, right? If we, I don't know if I rewrote it. No, I didn't rewrite it. So let me write it on the board here, where you could look at this as 6 times x squared cubed minus 2y squared cubed. Okay, and then the regular formula applies, where you use the x squared and the negative 2y squared, and then you have x to the 4th, 2x squared y squared plus 4y to the 4th. Okay, this one is a little bit more complicated. And so you might ask yourself, is it possible to factor this anymore? If this 2 was a perfect square, like if this had come out to be a 4 or something like that, we could factor it further, but we would involve the square root of 2 in this, and that's not the kind of factoring that we're looking for here. Okay, so then this thing that doesn't look like it has any common factors in it or anything like that, its basic form, because of that difference of cubes, says that it's prime there. Okay, so just to complete out the notes, you'll see that when you look up the notes. Okay? Okay, so let's now talk about factoring trinomials. When you think about factoring, probably the majority of the work that you've done up until now has probably been factoring trinomials. And so we have two special forms that we want to look for here. First one is if we have u plus v in parentheses squared, that this is going to make the u squared plus 2uv plus v squared. It's easy to make the mistake of just saying that this is the same thing as u squared v squared. It's not. Okay, you have that middle term of the 2uv. Same thing when you have the difference, you have that middle term come out. And you can prove this to yourself by foiling it. It comes out. But it's helpful sometimes to recognize that this is a special form, because as these factors of u and v get more complicated, it's easier just to check to see, do we have a perfect square here? All right, so let's go through a couple examples now. Okay, so the simplest case, we notice that the last term is a perfect square, the first term is a perfect square. So what we're going to test to see then, since the perfect square is x squared and 3 squared, we're going to take 3 times x times 2, and if that equals 6x, we have one of our special forms, and so that just becomes x plus 3 squared. Okay? Take a look at another one here. Let's say we have 16x squared plus 24x plus 9. Now, this one was a pretty simple one, and you probably could, regardless of the method that you use, factor that one fairly quickly. This one's a little bit more complicated because the numbers are a lot bigger. And so you think, okay, what's the easiest way to see if this thing factors? Well, look at the last term. That 9 should stand out as 3 squared. And then we look at the first term, and 16x squared is 4x. That's squared. So we're going to take our 4x, and multiply it by 3, and then multiply it by 2, and we get 24x. So this thing follows that form perfectly. So we take each of the outside factors, 4x and 3, and multiply it by 2, and we get 24, so we know that this thing then factors into 4x plus 3 in parentheses squared. Okay? Now there's other ways to do this as well, and we're going to get to those. All right, do a couple more examples here. We look at 49, recognize that as a perfect square. 4z squared is a perfect square, so we're going to take 7 times 2z is going to be 14z, times 2 is 28z. So this thing factors nicely. And we get, that says 2z plus 7 squared. Sorry, my handwriting kind of overlaps there. And I always cross my z's, you probably have noticed that. Okay, and next one, 25y squared minus 10y plus 1. Always recognize 1 as both a perfect square and a perfect cube. So we look at the first term in this, and 25, oh yeah, that's 5 squared. So we take the 1 times 5y will make 5y times 2 is 10y. But notice we have the negative, and if you recall, we have the form where it's the difference between these two factors squared gives us that negative in the middle. So there's the confirming thing that the form works, and so our answer is 5y minus 1 because of that negative. Okay, I can't say it enough. Factor out the common monomial factor because it sure will change the way these problems look. So we look at this, and initially we see a 3, 18, and 27. 18 and 27 are both factors of 3, so it looks like we can factor out the 3. And then we get x squared plus 6x plus 9, and that was that first example that I gave you of the square, so that one is just x plus 3 in parentheses squared. Okay, so we'll look at this one. And here we have a higher degree, x cubed. Well, what's the common monomial factor that you want to take out here? 4x, okay. So we'll get 4x times x squared plus 4x plus 4. And then how does that factor? Well, we have 4 is a perfect square, and x squared is a perfect square, so we take 2 times x is 2x times 2 is 4x, so this turns out to be a perfect square as well, x plus 2 squared. So why don't you try this one? Think in terms of all the things that I spoke about, factoring out the common monomial factor and among other things. Which is just what you did. Okay, very good. Okay, so I'm going to look at two different cases now of, or two different forms of a general trinomial. The first one that we're going to look at is factoring x squared plus bx plus c. So notice I don't have a coefficient on the x squared. So we're just going to look at this and see how does this happen. All right, so let's look at this x squared plus 5x plus 6. What we want to find are the factors of 6 that when you add those two factors, you get this middle coefficient. Because remember how FOIL works. You know, when you do the last, you're multiplying the two constant terms. When you're doing the outside and the inside, you're actually adding the coefficients then. So think about that, that pattern. So we're looking for the sum and the product equaling 5 and 6. And so this factors into x plus 3 and x plus 2. Okay, so if you went back and FOILed that, you would see that you get a 3x from the inside, you get a 2x from the outside, and that's what gives you your 5x. So here's the product, and there's the sum. So that's the whole thing, is looking at factors of c that add up to b. So here's another one, a squared plus 6a plus 8. So we look at the factors of 8, and we have 8 times 1, 2 times 4, 8 plus 1 equals 7, but we want 2 plus 4 equals 6. I do correct this here in just a moment. There you go, a 9. Right, heaven forbid that you'd write in your notes, well, my professor told me that 1 plus 8 is 7. Okay, so anyway, those are the possible factorizations of 8. And so we know that 2 plus 4 equals 6, and so we get our factors as a plus 2 and a plus 4. So I write these down to show you, you don't have to write them down yourself. In fact, probably when you're factoring trinomials, it's one of those things that you think, well, let me see, 2 times 8 is 6, or 2 times 4 is 8, 2 plus 4 is 6, and then you go directly from the problem down to the solution. And that's fine. Okay, when we're doing this by grouping, you're probably going to want to write a little bit more, and so we're going to get to that in a minute. But first, let's look at this. Okay, so we have y squared minus y minus 20. So we need factors of 20 that add to negative 1. So it's factors of negative 20. So we know one of them is going to be negative, and so we think about 20 as being 2 times 10, 1 times 20, or 4 times 5. Now 4 and 5 are different by 1, so what we get is we look at the differences between those factors. This last one is what we want, and so we get y minus 5 times y plus 4. All right, so now we're getting into some negatives, and there's some rules that you can think about that will help you factor it, and it'll help you decide which one do you make negative, which one you make positive, or are they both negative. So if we have this situation where we want to make x squared plus bx plus c. Now b and c in this case can either be positive or negative. So just because it says plus b, if b is negative, we know that at least one of these things is going to be negative. So I made up a little table here, and maybe it'll be helpful. And maybe it's, when it first comes out, is a little confusing, so I'll step through some examples pretty quickly. So if our last term is c, if that's positive, then we know that both factors have the same sign. Think about FOIL. When you're doing the last, that L, it's either a negative times negative or it's a positive times a positive. Now, if that c is negative, only one of them can be negative, right? It's a negative times a positive or a positive times a negative. So the factors that we're talking about, the plus and minus in here, one of them's positive, one of them's negative. Now, if we look at the b term after this, if they both have, or if c is positive, but b is negative, we know that both of those signs have to be negative. So both of these things in here have to be negative. If they're both, if it's positive, then both are positive. Okay, so we'll look at the last case, and then I'll run through some examples, and hopefully that'll make it clear. So here we have, if we have factors that have opposite signs, if b is negative, then the larger one is negative. If b is positive, then the larger one is positive. So that's when we had that x plus 5, or the x minus 5 times x plus 4, since we had a negative one. The 5 is larger than the 4, so that one is the one that gets the negative. So let me step through a few of these. Okay, all positive, both factors are positive. Have the plus sign in there. Now here we have the 6 is positive, the 5 is negative, and so that means we have the same sign, but since this is negative, that means they're both negative. So we'll have x minus 3 and x minus 2. Now here's a case where we have the last one's negative, so we know that they're going to have opposite signs. The b term is going to be positive, so we know that the larger one is going to be positive. So we know 3 and 2, the difference there is 1, and 3 times 2 is 6. So you know that the 3 is larger than the 2, so that gets the positive sign. If it was the other way around, where you would have minus x and minus 6, it's 3 times 2 makes 6, the difference is 1, and it's a negative 1, so it means that the 3 has the negative sign in front of it, and you get this. Okay, so it's just a way. Now, even when we're going to get a coefficient in front of this x squared, these rules will apply. So look at that last term. If it's positive, both terms will have a plus in them. If it's negative, only one of them will. Excuse me, when it's positive, they'll both have the same sign, either both plus or both minus. Okay, go through a couple examples here. So we have negative 18 and a positive 17. The fact that it says negative 18 means that the signs are opposite. The fact that the 17 is positive means the larger of the two numbers will have the positive sign. And so now we're looking for factors of 18 that add up. Well, since one's going to be negative, it's actually the difference, right? So it's going to be the difference between the two of them are going to be 1. Okay, so I'm making up a table of factors here. So it's either 1 times 18, 2 times 9, or 3 times 6 will get me my 18. I know that the larger one is positive, so I can write my pluses or my negatives in front of the smaller ones, and then add those up, and I get 17, 7, and 3. I'm looking for 17, so I know my factor is going to be negative 1 and 18. So when I factor that, it's going to look like this, where you have x minus 1 times x plus 18. So we take another one. Okay, x squared minus 2x minus 120. Opposite signs because the 120 has a negative sign in front of it. The larger one this time is going to be negative since the 2 has the negative sign in front of it. So we look at our factorizations, and we're going to have to see what multiplies to 120 that has a difference of 2. Well, that's not much of a difference, right? 2 is, so these factors are going to be pretty close together. So it doesn't make sense to start from 1 times 120, 2 times 60, 3 times 40, all that. Go to the middle, and you think, okay, well, 10 times 12 is pretty close. And in fact, that's what you're going to get, since 2 is much smaller than 120. We use 10 and 12. The larger one has the negative sign in front of it, and so here's our factoring. So looking at those negative signs is really going to help you a lot. Killer fly, right?
Yeah.
Okay. Now he's on me. So if B is much smaller than C, the factors are close together. If B, and I'm putting this wavy equal sign, is approximately C, okay, if B is approximately C, the factors are further apart. All right, just like we had up here, 17 is approximately 18, so these factors are far apart, 1 and 18. 2 is a much smaller number than 120, so we're going to expect the factors to be close together. Okay, so let's look at this one now. So we have a negative and a negative. So the fact that we have a negative in front of the C term means that the signs are going to be opposite. 15 is close to 16, so you're going to start with the farthest apart you can get in factors is 1 and 16. The difference is 15, and the negative sign is going to be the larger of the two factors, so it's going to be x minus 16, x plus 1.
Do we have to write the bigger number in the first?
No, it commutes. So you can write x plus 1 times x minus 16. And sometimes it just occurs to you what the factoring is. You know, you just kind of get a whole kind of catalog of rules, and sometimes it just jumps out at you, so pay no attention to order. Just put them in. Obviously, the negative sign has to be with the 16, but you know, the fact that you have x minus 16 second doesn't matter. Okay. Let's look at this. What do you think? What does the plus 96 mean? The fact that that's positive. What does that tell you?
Both factors have the same sign.
Yeah, both signs will be the same. Okay? And the fact that this is negative 20 means that they're both negative then. Right? So we have both negative. Now what we need is something that is that multiplies to 96 but adds to 20. Anybody have any idea?
8 and 12?
8 and 12, good. Okay, so we try 8 and 12, and sure enough that works. One of the ways you can do this is you can factor it out fully. And so what you do is you just group these numbers to give you all your factors. Like this would be, you know, you divide these in half here. You have 2 times 2 times 2 is 8. Then you have 2 times 2 times 3 is 12. So that's a good one to start with. And in fact, 8 and 12 equals 20, so those work. Okay, so enough of me, you try it. Now some of you have learned how to factor using this X, a little framework. You know, you put an X and you write numbers around it and that kind of stuff. If you know that, and if it works for you, I have no objection to you using it, okay? If you don't know it that way, I don't know, I don't teach it, it's not in the book, so you probably won't learn that way, but I guess my main point is that if that's the way you do it, and it works for you, great. Okay, so we got all of them. The 300 is a little bit bigger number, so you can factor that out as 3 times 10 times 10, or 3 times 2 times 5 times 2 times 5, and then by rearranging these numbers in various combinations, you can get the fact that 3 times 5 times is 15, and 2 times 2 times 5 is 20. So you can pick out your factors if you're at a loss for how to come up with pairs of factors. Just write all the prime factors out and grab some of the numbers for one factor, grab the remaining numbers for the other factor. Okay, So now we're going to return to this factoring by grouping thing, and this is the way I think is the, I wouldn't say it's the fastest way to factor when you have this coefficient a, okay? Up until now we've just had, you know, x squared, but now we're going to have something in front of there, this a factoring, and personally I think the most maybe not most straightforward way, the most direct way to factor this is doing it by grouping, because you're guaranteed to either find the factors, or if they don't exist, you'll know for sure that they don't exist. Okay, so it's going to be these 4 steps. We're going to take A and multiply it times C, and then we're going to factor AC to see which ones add to B. Then we're going to rewrite this middle group and then factor by grouping. Okay, so let me take you through one like that, and we'll see how this works. Okay, so I have 3x squared plus 10x plus 8. So step number 1 is multiplying the 3 times the 8, and I get 24. Now what I want to do is come up with factors that'll add up to 10. So one of the ways that I do this, and one of the ways that I feel you get definitively at the end, is that I start writing from 1 up my prime, or up all my factors until I get to approximately the square root of the number that I'm looking at. And so 24 is approximately 25, square root of 25 is 5, so I know I can stop here. And so then I write my other factors: 1 times 24, 2 times 12, 3 times 8, 4 times 6. Now if I went beyond 4, the next one would be 6, and then I would have 4. So I would have essentially a repeat of everything that I've done. So you won't repeat yourself if you go all the way or if you stop at the square root of a number close to the number that we're looking at. So now we apply our rules of positives and negatives, sums and differences. Since we have here 2 positives, we know that everything is positive and we're looking for the sum. And so when you add those terms, 1 times 24 is 24, but they add to 25. 2 times 12 is 24, and they add to 14. 3 times 8 is 24, adds to 11. And then here we get a 10. We look at that middle factor, and the 10 is the one that we're going to choose. So 4 and 6 are the 2 factors. And I'm going to rewrite my equation now to 3x squared plus 4x plus 6x plus 8. And it doesn't matter what order you put these in. I could have written this as 3x squared plus 6x plus 4x plus 8, and I would get to the same answer. So it doesn't matter, but you split those 2 things, split that 10 up into 4x plus 6x. Now factor by grouping. And so the first 2 we can factor out an x, the last 2 we can factor out a 2, and then we have a common 3x plus 4 that we can take out, and we get x plus 2 as our other factor. Now, this may seem like a lot of steps, and perhaps, you know, with small numbers you can just do it casually the way you do other ones. And that's fine. If you get to it, factoring is a little bit of a trial and error process. But when you do it this way, when you make up this table, if nothing comes up to adding your b term, you know that it won't factor. I mean, that's definitive. You can stop right there and say it doesn't factor. But once you get this, and you put these 2 factors into this expansion here, it's guaranteed to factor by grouping. Okay? It's absolutely guaranteed. You will be able to factor by grouping, and you will get to the full factorization. So in this sense, that if you go through this process, it is definitive. It'll tell you, can you factor it, and if it does factor, what does it factor into? Now, most people don't like to make up this little table here because it's a lot of writing, and you can do that in your brain. You can think, okay, what adds up to 10 that multiplies to 24, and maybe 4 and 6 jump out at you as 4 times 6 is 24, 4 plus 6 is 10. Then just go ahead and rewrite it like this, and then factor by grouping, and you're guaranteed to get to the right numbers there. Okay, let me run you through a couple examples now. 2x squared plus 9x plus 9. So I'm going to realize very quickly that 9, if I take 2 times 9, that's 18. And I can think, okay, yeah, 3 plus 6 equals 9, and 3 times 6 equals 18. So there are my two factors. I didn't make my table. I just went directly to realizing that the product, 2 times 19, is 18, and I can make both a 9 and an 18 by adding and multiplying those things. So I'm going to rewrite my polynomial to be 2x squared plus 3x plus 6x plus 9, and then factor by grouping. Factor the first 2 terms, second 2 terms, and then you factor out the common term, that 2x plus 3, and you get to be factored. Okay, so here's another one. 7x squared minus 13x minus 2. So what is the first thing that we do? We take the 7 times negative 2, and we get negative 14. Now, negative 13 is so close to negative 14 that we know immediately that this is going to be negative 14 plus 1 equals negative 13. And of course, negative 14 times 1 is negative 14. So I'll rewrite my polynomial to put a negative 14x plus x minus 2, factor by grouping, and then I come out there.